We are in Algebra 2, Lesson 2-2, still dipping our toes into the world known as complex numbers. Today's date is Monday, September 14th, 9/14, 2020. Who would like to read our objective for the day? Wyatt's the first one. Sorry, Josie.
Classify parts of complex numbers and graph them on the complex plane.
Yep, and I said this before, but the homework will go really, really, really quick tonight. You have 3 homework assignments. Each one can be done in about 30 seconds, as long as you're paying attention to my notes, right? So parts of a complex number. There are now 2 parts. There's the number that you guys know, this number right here, A. A number like A would be 2, 5, pi, e, 3.5, 7/3. Those are all numbers that you've known, right? You've heard them before. This is called the real part. But did you know that every single number that you've heard before, like 2, 5, 0, they all actually do have a complex part. It's just that complex part was 0. This right here is the imaginary part. So when I ask for the imaginary part of the complex number, you'll know that it's imaginary because it has an I attached to it. But when Khan Academy is asking you for the imaginary part, they're not looking for the I. The I only indicates that it is imaginary. They just want the B in front of the I. So do not write the I on Khan Academy. Do not type in, I guess, the I on Khan Academy. All right. And my whole analogy for complex numbers is it really is a shadow realm. And I hate the name imaginary because it makes you think, oh, it doesn't exist. And for a long time, imaginary was actually a word used to describe this field of mathematics to demean it, to say, you're dumb. You think this exists? It doesn't exist. By the way, it does exist. It's useful, and it has existed for a long time. I think, I'm trying to think of other mathematicians that use different words. It would be cool if we called this a lateral number or something. That would be a much better term for it. But I'm going to call it the shadow dimension because it makes it sound cool. All right, so generally speaking.
About Z?
What's up? Oh yeah, quiet raise hand, Gunnar. Thank you for remembering.
What about Z? Does Z have any meaning, or is it important?
That is a great question. So whenever I use the number or letter, variable, whatever you want to call this thing, Z, you should assume I'm talking about a complex number. It probably is going to have some sort of imaginary part. Z is kind of my general way of saying, hey, I'm talking about a complex number. Yeah. So complex numbers, they are everything that you know so far, unless you are maybe ahead of where I am. Wait, quiet raise hand. Does anyone know what quaternions are? Okay, cool. So everything that you know is a complex number. So a whole number, that's like the number 2, right? Whole numbers, 2. Whole numbers technically don't include negative numbers. A better term for this should have been natural numbers, if I could change this picture online. Numbers that you can count, these are the first numbers that people knew, how many sheep do I have back in the ancient days? I got 3 of them. Okay, those are your whole numbers. And then integers, that's when you start dealing with debt. You can have -3 all of a sudden. And then rational numbers, I can think of as parts. I can think of 1.5, or I can think of 2/3. I can start thinking of fractions or decimals, stuff like rational numbers, okay? And then you get to real numbers, which has both rational and irrational numbers. So what is an irrational number? That's a number that you've seen before. Square root of 2, that's irrational. Irrational just means it has a non-terminating, non-repeating decimal. Yes, 1/7, if you look it up on your computer by doing your Spotlight search command space, 1/7, it looks like it doesn't repeat. It's 1.142857, but then it repeats again, 1.42857, 1.42857. Yeah, what?
Would pi be an irrational number?
Yes, pi. You stole my thunder. I was going to do pi. And then how about this one? You can't steal my thunder. And this one, E. E is an irrational number. Euler's constant, or some people have a few names for this. But yeah, they're those special letter type numbers are irrational numbers. Square roots of most things are going to be irrational. Square root of 4 is 2, so square root of 4 is not an irrational number. But most square root numbers are going to be an irrational number. And then real number just glues together rational and irrational number. There's not a number that is neither irrational nor rational that is a real number. A real number just glues those together. There's nothing out in this area right here that doesn't exist. Okay, so you guys know real numbers really well. And the level of depth that we're getting right here is the shadow dimension, which is this imaginary number. Imaginary number just is an I, right? You learned about that yesterday. I is an imaginary number. 2i is an imaginary number. Pi I is an imaginary number. Square root of 2i is an imaginary number. It just means that you have an I next to it. So you can just put an I. Well, there's an imaginary number. And then just like real numbers glues together rational and irrational, complex numbers glue together real and imaginary. I mean, that's the definition. Look, real and imaginary. That is a complex number. So the main thing that I want you to take away from this chart is everything, every number that you know is a complex number, because everything that you know is a real number. And real numbers are also a type of complex numbers. Eventually, I would be asking you guys questions on what type of number is blank. You don't even know what blank is. Go ahead and scratch it off. It's going to be complex because everything is complex, because it is at least real. If it's real and imaginary, it's complex. If it's just imaginary, it's complex. If it's just real, it's complex. Everything is complex. C will always be an answer on Khan Academy because everything is complex. And I think that should be like the logo of a shirt that we make for this class. Everything's complex. Like life is complex. Everything's just complex, right? But it is true. When we're talking about math in terms of our numbers, everything that you know is complex until you get to college level math and you learn about quaternions and a bunch of other cool things that would like have weird intersecting other bubble charts. But that's us right here. Questions up to this point? Everything is complex. All right, let's do an example. This example is asking you, hey, what is the real part of Z? And hey, what is the imaginary part of Z? Again, don't write the I, only write the number in front of I. Can I get some hands that haven't spoken yet today? What is the real part of Z? And it's not a trick question. Jade.
6.
6, done. And then be careful, the sign is important for the imaginary part. What is the imaginary part of this? Someone new. I see Andres' hand.
Oh, me?
Yes.
All right. So would it be negative 4i?
Careful. You never want to write down the I.
Oh, yeah. Negative
negative
4, negative 4. Yeah.
Yeah. Yep. There you go. Thank you. It's that easy. That is one homework assignment right there. Done. We're on to the second homework assignment. What type of number is 104i minus 33.24? Okay. As I said, you always choose this one answer. I'm not going to repeat it because now you have to actually be paying attention, right? But it might be real, which means it's not imaginary. And it might be pure imaginary, which means it's not real. So you could have an answer like this. But you can't choose all three of them. If it's all three of them, it's just C, right? Real just means it's only real. There's no imaginary part. That means real, you're in the real section without being in the imaginary. You're not touching this realm over here. So example 2. What do you think? You can choose multiple. And yeah, why you did the objective, right? Yeah, so let's give you some math and then you're participating for math of the day.
I think it would be complex and pure imaginary because it has the I.
Okay, yeah, it's a good guess, and it's actually not quite right. So pure imaginary means that there's no real, but 33.24 is a real number. So it's actually just pure complex. It's just C in this case. Yeah, Gunnar, question?
I was going to give the right answer, but
Oh, we're going to just say C?
yeah.
Okay, yeah, you would have gotten it correct. Good job. Typically speaking, if you have two numbers here, it's just going to be complex. And if you have just one number, like just 104i, then that's when it's going to be pure imaginary. Or if you just had 33.4, that would be just real, and everything is always complex. Question, Andres? Are you ready for the next one? Is that
Yeah, no, question. So you said that it could never be all three answers, or?
It can never be all three, yeah.
Okay.
All right, example number 3. What type of number is 78? I've seen 78 before. I saw that in kindergarten. Wait, that's complex. Yeah, it was. Yeah, Charles?
Would it be just real?
So just A like that?
Yeah.
Kind of. But remember, I said at the very beginning, you're
yeah,
always
you
going to
said it was
choose.
complex.
Yeah, so the answer is A and C.
So pretty much you only would choose just imaginary or complex? Not just real?
No, this one's real. There's no imaginary part. There's no I. So this one is real.
Oh, so
I'll
you choose
circle
both
A.
of them.
And then, yeah, exactly.
Okay.
So another way of thinking about these guys is where does your number live? How far deep inside your graph do you live? Maybe your number was a whole number. Like we chose, for example, 78. 78 belongs right here. 78 is a whole number. 78 is a whole number. 78 is also an integer. 78 is also a rational number. 78 is not an irrational number, but 78 is a real number. It is a complex number, but it is not an imaginary number because 78 lives over here and it doesn't intersect either of these two things. So 78 is everything that you know, except for it's not irrational and it's not imaginary. Okay. Give me a fist of 5 on how well you think you know how to choose real, pure imaginary, or complex. I'm getting lots of 4s and 5s, a 3 from Jose. Jose, do you have a clarifying question? A 4 from Jenny. Any questions, Jose, that you can help make? Okay, yeah, I guess the Khan Academy assignment will make that clear. But yeah, let's move on to plotting complex numbers. So complex numbers have two axes, if I'm thinking about them graphically. Before, graphically, we had a y-axis and an x-axis, right? Y and x. We still have two axes, but they're not x and y anymore. Our axis that runs left and right, we're going to now call that our real axis because, again, complex numbers are made out of two parts. So someone new, take a guess, what do you think our vertical axis, the one that runs up and down, is going to be? If the one that is horizontal left and right is real, the vertical axis must be the... Someone new. I see some hands, but sorry, I'm going to call on someone that I haven't called on before today. Do I need a cold call? Cohen.
Imaginary.
There it is. I'll just write down IM, Cohen's imaginary axis. Yeah, and therefore, whenever I am looking at a complex number like -6 minus 3i, I'm going to go -6 on the real axis and -3 on the imaginary axis, and that is going to be a point. So this thing right here, let's label this. This is a complex plane. The old one that you used to have, so I can do it off to the side, the one that had x and y, this was called the coordinate plane. Coordinate plane. We're no longer dealing with the coordinate plane because we need to somehow represent that shadow dimension, that imaginary number. And so we use the complex plane. And any point on here, so if I have, I'll say any point on here is a complex number. So if I want to graph, no, technically 3 is a complex number, but if I want to graph 2 plus 4i, that's that point right there. That's 2 plus 4i. If I want to graph -3 minus 7i, I could graph that as well. No matter what sort of complex number you have, it could be pure imaginary and pure real too. They are all on the complex plane. For example, if I want to graph 4 is just real, but not imaginary. If I want to graph something that's pure imaginary, like how do I graph I? Where does I live? I is right here. This number is 4. This number is just I. Before, there was no way to graph I on the coordinate plane. You would have had to have some sort of third dimension, which would be really cool, by the way. Like, if you really want to think of like x, y coordinates with real numbers, you could think of like coming out of the paper with that x, y coordinate plane. All right, let's do some easy problems. Example 4, plot -6 minus 3i on the complex plane below. Gunnar already has it, or is it a question?
I already have it. I was doing it as you were explaining the graph.
Awesome. I'm going to give some more thinking time to other people. Also, I'll probably call on someone new just to get more people to participate, more voices, gain confidence. All right, so the way that you're going to help me answer this is if I start at the origin, it's still called the origin on the complex plane too. If I start at the origin, where do I go? Do I go left, down, up, right? Help me. I mean, typically if it was in a classroom, you'd come up and do this on the board. But because we're on Zoom, tell me how much left, how much right, how much up, how much down to go from the origin to get to the, it's not really coordinate, to get to the number -6 minus 3i, that complex number. So someone new, sorry, Gunnar. Someone new, tell me where to go from the origin. I see Charles's hand. Thank you, Charles, but I'm going to give it to someone new. I will cold call on someone. Unless it's someone that wants to volunteer. All right, Jenny. Yes, Jenny. Where do I go from the origin?
I don't know.
I'll help you out then. All right, so we know that the real axis goes left and right. The imaginary axis goes up and down. So -6, is that a real number or an imaginary number?
A real?
It is a real, you're right, because it doesn't have any imaginary I unit next to it. So there's no I. So that means this 6 is telling me how much to go left and right. Do you think we should go left 6 or right 6 then?
Left?
Yep, left is negative, so I'm going to go left 6. So I'm right here. And then what about this? -3i. What do you think that means in terms of going up, down, left, right?
Down right?
Down, right?
I don't know.
Okay, so you're almost there. So it's either going to be up or down because the imaginary is only going to go up or down. Is it going to be up 3 or down 3?
Down?
Down 3, yep. And there is Jenny's point, -6 minus 3i. All right, thank you. And let's try another one. On that same complex plane that you have drawn, go ahead and graph -2 plus I. And Fernando, I'm giving you a heads up, you're going to be the one that answers this one. Where is -2 plus I? When you're ready to say the answer, Fernando, just let me know. All right, go for it.
All right, so you're gonna go left 2 and then up 1.
Yep, there it is. Thank you. That's -2, not comma, plus I. Don't ever do a comma because that's a coordinate. That's a coordinate pair, right? It's just, you just add and subtract them. That's all I got for you guys. That's the end of the notes. There's nothing.
Can you tell us your fraternity stories now?
I guess. Before I do that, fist of 5 on our objective today. So our objective was classify parts of complex numbers and graph them on the complex plane. What are you guys giving me? 5, 5, 4, 10, 5, 5, 4, 5, 5, 5, 4. All right, yeah, those are nice.